Students, welcome to UIST-BLS. In previous class, we have discussed the classification of matter, physical classification, chemical classification, and the classification of pure substance. So, we classify the pure substance into two types. One is element and other is compounds. We already discussed what is element, what is compounds. Today we will discuss what is the classification of elements. So elements are classified into three types. One is metals, second one is non-metals, and next one is metalloids. So what is metal? Metal is the good conductor of heat and electricity. Metal is the good conductor of heat and electricity. That means it conducts heat and electricity. That means it conducts heat and electricity. Heat and electricity. Electricity. It conducts heat and electricity. Another feature one. And metal also have luster. Metals have luster. It has ductile. It has ductile. It has ductile. But in non-metal, it is not good conductor of heat and electricity. Not good conductor of heat and electricity. Heat and electricity. And it has no luster. It has not ductility capacity. So you also can take example. Conductor means iron. We can take example iron, copper. These are the examples. Non-metal. You can take example. Nitrogen, oxygen, iodine. These are the examples of non-metals. And what are metalloids? Metalloids has both metallic character and non-metallic character. That means it has both metallic character and non-metallic character. So also you can take example arsenic. You can take example arsenic, bismuth. These are the examples of metalloids. So this is the classification of elements: metal, non-metal, metalloids. So in previous class I have discussed the compound classification. One is inorganic compound, another is organic compound. And also classification of mixture. One is homogeneous, another is heterogeneous. Homogeneous mixture example, heterogeneous mixture example I have already discussed in previous class. But the important is that today I will discuss what is the difference between compounds and mixture. definition and mixture definition. But what is the difference arises in between compound and mixture? So what do you mean by compounds? Two or more elements combined together in a fixed ratio. That is called compounds. You already know. You are already known in previous class. And what is mixture? Two or more constituents combined together in any ratio. That is called mixture. One word difference between compound and mixture is compound is formed by the fixed ratio. Mixture is formed by any ratio. Okay? So we can write the difference between compound and mixture. We can write the difference between compound and mixture. The difference between compounds and mixtures. Compound and mixtures. So compounds, two or more elements combined together in a fixed ratio to give compound whereas mixture are the substance two or more constituents two or more constituent substances mixed together in any ratio to give mixture. So the important is compounds are formed in a fixed ratio. Mixtures are formed by any ratio. So compounds, second one, what is the second one? Compound formed by chemical classification, by chemical change, but mixture formed by physical change. Compound is formed by chemical change, but mixture is formed by physical change. That means you take the reactant, two reactants, when mixed together to give product. The two reactants may be elements when it mixed in a fixed ratio to give compounds. But elements have the properties which is different than compounds properties. Compounds is unique properties which is different than elements properties. You can take example that carbon dioxide is formed from carbon and oxygen. Okay? So carbon has unique property, oxygen has unique property. When it meets together, carbon dioxide has another unique properties. That means compounds have the chemical property which is different than elements chemical property. Okay? So compounds are formed compounds are formed by chemical change. Whereas mixtures are formed by physical change. Mixtures are formed by physical change. Compounds are formed by chemical change, whereas mixtures are formed by physical change. And next one is compounds formed. That means compound may homogeneous. Compound forms always homogeneous, but mixtures may homogeneous or not. Compound always formed by homogeneous. That means compound always homogeneous. Compounds are homogeneous, but mixtures may homogeneous or may not. Mixtures may homogeneous or may not. That means may homogeneous or heterogeneous. May homogeneous or heterogeneous. So these are the basic difference between compounds and mixture. So you can take examples of compound carbon dioxide. Here, in case of carbon dioxide, carbon is 1 and oxygen is 2. That means carbon dioxide is formed by 1:2 ratio. That means fixed ratio. An example of mixture is that constituents mix together in any ratio. So here the example is gaseous mixture. That means the constituents in the mixture of gaseous has not same quantities. Different quantities gases are in gaseous mixtures. Okay, are you clear about it? So the difference between compounds, mixtures, what is mixture and what is the classification of mixture, I have discussed. The classification of mixture I have discussed in the also previous class. Okay, so you know about it. So the basic difference I discussed today: compound, mixture. The difference. What are the different? What are the examples of compound and mixture? Okay, so today I will discuss a very much interesting questions. I will give a task and you will say the answer. Okay, so I will write it. So you all know the clock. You all know what is the value of time. Nowadays, time is very much important. As a chemistry student, days. Okay, so we will play throw a watch. You know, this is like a watch, wall clock. Okay, so hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. That means atomic number 1, 2, 3, 4, 5 and 6, 7, 8. Then fluorine 9. Then neon 10. Sodium 11 and magnesium finally 12. This is chemistry watch. This is chemistry watch. This is chemistry watch. This is chemistry watch. Okay. In chemistry watch, then you say, what is the time of now? This is a task for you. You will identify the time. It is how much time. You will identify and give it in the comment section. How much time it is. And you all know about the hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium and magnesium. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is atomic number. So, as you are a chemistry student, you will find out what is the time of now and how much time it is. You will give it in the comment section. We will wait for you, and I think you all are very much interested for this class. That's why we will grow day by day, and we will discuss very much questions day by day. You will interact with us and give your question. We will give that answer, and we will discuss in an entertainment way, and in the so that the class will be very much interested. Okay, so if you will feel so happy, so I will discuss another question also. I will discuss also another question. It will be very much valuable for your competitive exams. Okay, it is also very much valuable for your competitive exams. Okay, so you all know about resonance, hyperconjugation. I will discuss after some days this one, but a question I will discuss. Okay. Question I will discuss. The question I will discuss stabilities. Which one is more stable? Which one? Which question is which allylic carbocation? Which allylic carbocation? Which allylic carbocations are which allylic carbocation is most stable? Most stable. Okay, so this one, this is the bond line formula. This one, and this one. All are allylic carbon. This is option number A, option number B, option number C, and D. All have same stability. All have same stability. This question is very much valuable for your entrance exam. So all are allylic carbocation. All are allylic carbocation. All are allylic carbocation. All are allylic carbocation. So which one is more stable? This position is allylic position. This position is allylic position. This position is allylic position, and this position is allylic position. Because double, single, plus, double, single, plus, double, single, plus. That means here is the conjugation. Here is the conjugation. Alternative double bond and single bond is called conjugation, and also double, single, plus. That is also conjugation. So if we have conjugation, here resonance possible. Here resonance possible. We will discuss in organic chemistry. You have to wait for that moment. We will discuss. But today I will discuss due to some entrance exams. So you already have to know. Okay? So here also resonance. This allylic position also resonance. This allylic position also resonance. Okay? And this allylic position also resonance. You feel all have same stability. But what is the difference? But what is the difference? Something different from others that has more stable, we have to identify. Here here 2 alpha carbon. This is carbon pattern. That neighboring carbon is alpha carbon. Neighboring carbon is alpha carbon. That neighboring carbon is alpha carbon. Okay. So here there is 3 alpha hydrogen. If alpha carbon is present, then that hydrogen is called alpha hydrogen. That the adjacent carbon of functional group, that is called alpha carbon, which contain that hydrogen, that is called alpha hydrogen. Clear? So here carbon pattern, the adjacent carbon here, the adjacent carbon is called alpha carbon. It has 3 alpha hydrogen. It has 3 alpha hydrogen. But it has here 3 alpha hydrogen. This alpha carbon has 3 alpha hydrogen. Resonance. But according to hyperconjugation, another term hyperconjugation, more is the number of alpha carbons, more is the hyperconjugation, more is the stability. So here 6 alpha hydrogen atom, here 3 alpha hydrogen atom, here hyperconjugation, here hyperconjugation, here a hyperconjugation, or there is no hyperconjugation. If it has hyperconjugation 6 alpha hydrogen atom, so this one has more stable in comparison to this one. Here resonance plus hyperconjugation, here resonance plus hyperconjugation. So this resonance plus hyperconjugation, that means B and C is are more stable than A. But between B and C, which one is more stable? Here hyperconjugation, here also hyperconjugation. You have to know if more is the alpha hydrogen atom, more is the hyperconjugated structure, more is the stability. So option C has more hyperconjugated structure because there is 6 alpha hydrogen atom. So more is the stability. So C is more stable than B is more stable than A. B is more stable than A. So C has resonance hyperconjugation, B has resonance hyperconjugation, but it has resonance. But here is more alpha hydrogen atom, so more hyperconjugated structure. So C is more stability. So C allylic carbon is more stable than B allylic carbon is more stable than A allylic carbon. I think you will give your question also in our comment box related to this topic, and we will wait for that time. So thank you for the classes. We will discuss in the next class.